with particular reference to virtual reality and 3D printing, how the usage of these digital technologies is actually changing the space industries. Could you expand on that, please?
Yes, okay. That is a big change now. Yeah, because that's not only technology, but are really new methods that enhance our intelligence. If you think a spacecraft, like one I have in the hand, is like a box. So we are trained to see spacecraft like big box filled of box. This is changing completely, because when we have to design this new spacecraft now, thanks to the printing and augmented reality, then change completely, falls completely the limit of the shape that now are at the present. So now in the design, for example, you have to imagine new shape that now are feasible thanks to the 3D printing. And by virtual reality, you can also verify that these new shapes works correctly in the side of integration and can really fit even the new production that is even allowed by 3D printing be different by the previous one. So now the shape is not more a limit, and the limit is the human imagination. But thanks to this digital change, then this imagination is now more powerful and help you to find solution that was not possible since now. And that is a big revolution. And then it is a big revolution in the design, in the verification, and in the production. So we imagine new shape for new performance versus also our customer. And we produce a change file in our factory in Morocco, even in a new way. And that leads to a new competitiveness.
Okay, guys, so probably could you tell us how are you using virtual reality in the space manufacturing context?
Yeah, so we started from some years ago using these new technologies, mainly it's virtual reality and augmented reality, in the whole life cycle of our satellite products. In fact, the virtual reality gives us an environment that is, as you know, controlled. It's an immersive system. You can see here some example of the usage of our system, for which with your hands you can build up a system. So you can choose a piece, put them together, and start to build the real satellite, so the one that you will see at the end produced, in a controlled environment. So we are going to use in all our phases, in all our activities, starting from the design, for example, our engineers go to the virtual environment, start to pick up pieces, put them together, and figure out them solution. In this case, they can go fast to the prototyping system, so they can prototype it. So starting from this, they can build, they can have a 3D file, send it to a manufacturing 3D factory, and have this prototype, so they can figure out and can work with it. The same is applying for the manufacturing phase, for which having a virtualized environment, even an augmented one, can help you to answer in anticipation to some usual question we have when you are going to start our manufacturing. For example, you can answer, is it possible to build this kind of satellite in this area? So you can figure out the space, you can move the satellite in your single pieces inside of it, and you can even check if it works. Same, it applies also in the velocity, let's say, in which you are able to manufacture and produce your system. You know, thanks to the virtual reality, you can decide to have particular shapes that are then be produced, let's say, in an easier way, and can fit with particular missions. You know, in the case of that you are looking in the screen now, you can see a different shape of a satellite that is getting inspired by nature. For example, it is inspired by a ladybug. So you see these curves in which we build up our satellites that gives us the possibility to enlarge the production of electrical power by sun. In fact, the fact to have curves in the wings of the ladybug give us the possibility to collect more solar rays that can be used in the production of the system. The same approach for the virtual reality is also important for us in the relation with our customer. In fact, our customer can come and see the solution we are going to propose. So they can see how the final satellite will look like and which are the main functionalities and performances that the system can reach at the end. Even in the post-delivery phase, it's important to have this virtualized environment in which we can enter and we can check what is happening in case of problem or even in case for let's say, training of the people that have to use it. So, I repeat, in each phase of our production, the virtual reality is really important to figure out and understand what we want to realize.
So it was important to mix these two technologies actually to achieve that, right?
Yeah, sure. It's really the basis of our work today. You know, you can start working an idea, and instead to produce it and verify after that it doesn't work, you can use a virtualized environment and check that in that place if it works. You can even reduce the risk in the production. You can be really fast in answering to a question, but you can also, you put your innovative part, all your ideas inside a tool that gives you the possibility to check if what you are thinking is really something that sounds good. And this is what we did up to now. You know, it's for our new ideas of satellites. You know, we have some concept satellite that we realized that thanks to the merging of the two technologies that we mentioned. So it's virtual reality and 3D printing, putting them together, they are helping us in producing new concept satellite.
That's,
you know, please.
That's really exciting. I don't know if you wanted to add something before we conclude here.
Yeah, just to tell you some information. Up to now, we already started working with the additive manufacturing, so with 3D printing system, and we have thousands of pieces that are in space today. And thanks to this, we started in developing a new concept satellites. I repeat, we get inspired by the nature, and thanks to what we see, we transformed it in a real new technologies element that can be used for new mission that up to now have been never discovered. You know, thanks to the fact that we have no shapes or we are not fixed in a kind of shape, we can use different technology to cover with different mission. Example of this could be the fact that thanks to particular curves that we can produce and apply as antennas on our spacecraft, we can get signals that in the past element was not possible, and we even use that for additional application like weather forecast or similar one.
All right, guys, thank you very much for sharing.